So it turns out that you can have roots based on any number. They don't just have to be square roots. You can have cube roots or fourth roots or fifth roots. So today we're going to look at how to simplify a root that is not a square root. And we're going to compare these to the square roots we've been doing so that it'll make sense how we're doing these new kinds of problems. Okay, so let's look at this one. This one's a square root, which is what we've already been practicing, and this one's a cube root. Okay, so it starts off the same way no matter what. We're going to start off with a factor tree. So 72, that's 36 times 2. 36 is 6 and 6, and each one of those 6's is 2 and 3. All right, and so I'm going to go through and I'm going to cross out all of my composite numbers so they don't cause me any problem while I'm trying to simplify here. And then I'm going to circle my pairs. So I have a pair of 2's right here, and I have a pair of 3's right next to it. And then don't forget this 2 way up here at the top. So when I get ready to write my final answer, I have a 2 and a 3 inside the circles. 2 times 3 is 6. And I'm going to leave a space right next to the 6 here to put my variables. And then this 2 that doesn't have a partner, this 2 goes on the inside. All right, now let's look at my exponents. So remember when we were doing with square roots, what we've been doing in the last several videos, when you work with a square root, what do you always divide by? You're always going to divide by 2. So I have a 3 right here. 3 divided by 2. 2 goes into 3 one time, whole. So I'm going to put the A to the first right there with 1 left over. Right? Remember how many times it goes in goes on the outside, and the remainder goes on the inside. Okay, so let's do B. Let's divide that one by 2. 2 goes into 8 4 times. So I've got B to the 4th. Oh, that's a terrible looking 4. Let's see if I can make that a little bit better. All right, B to the 4th with none left over, so nothing right here. And then remember we talked about if you had an odd exponent, you want to put those absolute value bars on there. Okay, so now let's look at this one. So now we're doing a cube root, but we're going to start off the same way. Well, I'm going to use these same prime factors because 72, 72, right? It doesn't matter. I'm using these same prime factors right here. I had a 2 and a 3, a 2 and a 3 and a 2. Okay, so when we did square root, think about what square root means. Square root means a number times itself, always 2. So we circled pairs. Well, a cube root, what we've got over here, a cube root is 3 because cube means a number times itself times itself. There's 3 of them. So when we get ready to do our circle, instead of circling pairs like we did before, we're going to circle groups of 3. So all 3 of those 2's will go in the same circle. And the 3's, see, they don't get to go in a circle because there's only 2 of them. And for a cube root, I need 3 of them in the circle. So that means that 2 gets to come outside because it's in a circle. And those 2 3's have to multiply back together on the inside. Now remember right here, you want to be sure to put that little 3 so you can show that this is a cube root and not a square root. Okay, well if I had to have 3 numbers in my circle, because cube is a number times itself 3 times, what number do you think I'm going to divide by on my exponents? Well, I'm going to divide by 3 because it takes 3 now to come out of the house instead of just 2. So when I divide by 3, 3 goes into 3 one time with none left over. So just like what we did with square roots, the number that's on the top, the number that it goes in that many times, tells us what goes on the outside. And the remainder, what's left down here on the bottom, tells us what goes on the inside. So in this case, 3 goes into 3 one time. So I'm going to have an A out here on the outside. And there are none left over, so I'm not going to have an A on the inside. Okay, let's do the same thing with B. I'm doing a cube root, so this time I want to divide by 3. 3 goes into 8 2 times. 2 times 3 is 6 with 2 left over. Okay, now just like before, the number that's on the top, this tells us what goes on the outside, and the number on the bottom tells us what goes on the inside. So I'm going to have b to the second on the outside because 3 goes into 8 2 times. And I'm going to have b to the second on the inside because there's 2 left over. Okay, so now here's a difference between square root and cube root. Remember, for square root, because there was an understood positive out here, I needed my final answer to be positive. That's why I had to have those absolute value bars on the odd exponent. However, for a cube root, think about for cube roots. If you multiply 2 times 2 times 2, you're going to get positive 8. It's okay to get a positive number when you cube. And if you do negative 2, well, negative 2 times negative 2 times negative 2 is negative 8. So this one doesn't necessarily have to match. It's actually going to match the sign of whatever's inside of here. So this one, 72a cubed b to the 8th, I don't know what a is. So if a is a positive number, then this a is going to be positive. If a is a negative number, this a is going to be already negative. So I'm not going to put absolute value bars when I have a cube root. I'm only going to put absolute value bars when my root is even, like a 2 or a 4. Never when I have an odd root, like a 3 or a 5, because whatever the sign of this one is going to match the sign of this one, the sign of this one, matching the sign of that one. If I put absolute value bars on it, I might change the sign, so I'm not going to do that. So my final answer for this one is going to be here with no absolute value bars. That is my final answer. Okay, let's look at something else. Something else that is similar and something else that is different. Okay, so just like before, when I have 1,125, I'm going to do a factor tree. All right, so it ends with a 5. Let's do 5. 5 goes into 11 2 times with 1 left over. 5 goes into 12 2 times with 2 left over. 5 goes into 25 5 times. So 5 times 225 equals 1125. And I've got that negative out there. Don't forget, I've got really like -1 times the square root of 1125. Okay, so let's factor 225. 225, 5 goes into 24 times, 5 goes into 22 5 times. All right, 45. 45 is 9 times 5. Now we're getting to some numbers we recognize. 9 is 3 times 3. Okay, so I'm looking at a square root right here. And you remember when I've got the square root of a negative, when I have this -1 right here, well, what by definition is the square root of -1? Well, that's going to be I. That's where my I comes from. So when I get ready to circle my pairs, I need to remember that I also need to put an I on my answer because the square root of -1 is I. Okay, so what is going to go outside the square root symbol? The ones in the circles. So 3 times 5 is 15. And then don't forget, I've got this I right here. And the one that's not circled, the 5, is going to go on the inside. And of course, it is always okay to go back and put X's through your composite numbers so that those don't get you messed up, right? Put X's through all your composite numbers, and that will help you focus on what is prime. Okay, so let's do the same thing over here. This time I've got a cube root, but the factors are going to be the same, right? 1,125, 1,125, it's the same. So I'm going to have 5, 5, 3, 3, 5, just like I did before. Okay, now think about what we did in the last example. When I have a cube root, when I've got a 3 right here, how many do I need in my circle? Well, I need 3. All right, so I've got 3 5s, and then those 2 3s, they don't get to be circled because I only have 2, and I need 3 because it's a cube root. Okay, so when I had the square root of a negative, square root of -1 is I. By definition, that's what that is, but not cube root. Remember we looked at on that last slide, when I have a positive number cubed, I can get a positive number. When I have a negative number cubed, I get a negative number. So I don't need to use I on this one because it's okay to take the cube root of a negative. If you were to type this in your calculator, the calculator would just give you a negative answer because whatever the sign is in here matches the sign of your answer. So because this negative is right there on the inside, then when I go to write my final answer, instead of just writing 5, I'm going to write -5, and then I'm going to multiply the 3's back together on the inside, -5 and a 9. Okay, what did I leave out? Well, I forgot to put my little cube right here. Remember, that says 5 square root of 9. Well, if I start off with a cube root, I can't end up with a square root. If I start off with a cube root, I've got to end up with a cube root. So I should put a little tiny 3 right there so that I can see I've got a cube root of 9. So -5 cube root of 9. Okay, so look at this one. Now I'm going to do a cube root because we've already practiced those a couple times, and I'm going to compare that with a 4th root. Okay, so what is going to be the first step? Well, the first step is still to do a factor tree. So 648, let's start off with 4. You might need your calculator on some of these because the numbers are going to be larger. 4 goes into 6 one time, 2 left over. 4 goes into 24 6 times. 4 goes into 8 2 times. All right, well, 4 is not prime, so let's factor that again. 162 is not prime. Let's factor that one. I can see it's even, so let's do 2. 2 goes into 16 8 times. 2 goes into 2 1 time. All right, 81 is not prime. Let's factor that one. And 9 is not prime, so let's factor those. Okay, so now let's go through and circle. All right, now pay attention. I've got a cube root right here. So how many numbers should go in each of my circles if I'm doing a cube root? Right, I should put 3 numbers in each of my circles. So I've got a set of 3 2's right there. I've got a set of 3 3's right there. And just like we did before, I'm going to cross out all my numbers that are not prime so I don't get mixed up. So I can see I've got these 3 2's, I've got these 3 3's, and then I've got that one extra one right there. Okay, so to go on the outside, what am I going to have on the outside? Right, on the outside I'm going to have 6. 2 times 3 is 6. Leave a space for my variable. On the inside, I'm going to have a 3. Don't forget to put that little cube root right there, right? Because if you start off with a cube root, you got to end up with a cube root. Okay, now, what should I divide my exponent by? Good, I'm going to divide my exponent by 3. 3 goes into 7 2 times with 1 left over. I'm choosing 3 because it's a cube root. Always divide by whatever your root is. Square roots you divide by 2. Cube roots are going to divide by 3. Okay, so the x. I have a 2 and I have a 1. The 2 should go where? The 2 should go on the outside because it's up on top. And the remainder, what's down here on the bottom, that should go on the inside. X to the first, or just plain x. Because it's a cube root, I don't even need to think about absolute value bars. That's going to be my final answer, 6x squared times the cube root of 3x. Okay, now let's do 648. All right, just like we did before, I'm not going to go through the factor tree again because it's going to be the same factor tree. I'll just write the numbers down. I had 3 2's. And then I had 4 3's. Okay, so think about this for just a second. When we had a square root, we circled 2. When we had a cube root, we circled 3. So what do you guys think for a 4th root? I think we need to circle 4 because it's a 4th root. So I have 4 3's right here. All right, and those 2's, I don't have enough. You have to have 4 in a circle, and I only have 3, so that's as much as I can do. So just like all the other ones, the thing that's in the circle comes on the outside. I've got 3. The numbers that are not circled, I'm going to multiply those back together on the inside. So 2 times 2 times 2, that's 8. Okay, now let's look at our exponent. So when it was a square root, we divided by 2. When it was a cube root, we divided by 3. So now it's a 4th root. We're going to need to divide by 4, right? So let's do that. I'm going to divide 7 by 4. 4 goes into 7 one time with 3 left over. Okay, now just like the other ones, this one goes outside. And just like the other ones, this one, the remainder, goes on the inside.